to start with, what could you plug in for x here to make this statement true? 3, right? Is there anything else that you could plug in for x that would make this a true statement? No. Not just one single thing, right? There's not one single thing you could plug in for x and make this a true statement. Everybody agrees with that? Just 3. 3 equals 3, that's the only true statement. But if you change this problem to this, remember what this symbol is again? That's greater than. We'll talk about these in just a second. How many things can you now plug in for x that make this true? There'd be a bunch, right? 4, 5, 5.5, 6, and it could just go on forever, right? It'd be an infinite amount. There'd be an infinite amount of things you could plug in here to make this true. This is a greater than sign. X greater than 3. Okay? So what we're going to talk about today are these symbols. And together, I'll remind you what each of them are. But together, does you remember what those are called? Like the whole group of them? I mean, they're greater than, less than, greater than, equal to, less than, or equal to. But what's the whole group of them called? Everybody know that? If an equal sign is called an equality, what do you think these are? You remember these? These are inequalities, right? That's what we're going to be talking about today. Inequalities. If you want to know where it's at in your book, this is the start of chapter 6. Okay. We're going to be talking about inequalities. So let's go through what each of these symbols are again. Okay, remember you always look at them from left to right. So this one was what did we say? That was greater than. So that makes this one less than. This one, when you have the bar underneath, means what? Or equal to. So it's greater than. And if you already know these, you don't necessarily need to write these down, but it might be a good idea to have. Greater than or equal to. So that one's less than or equal to. Okay. So we're going to be using these today and talking about how we use these in some math problems. Okay. Now, there's a bunch of different ways that people remember these. Some people forget. It's a good idea to just have it memorized, but just about inequalities today. Okay. So like we said earlier in this problem, there's an infinite amount of things you could put in for x to make this true, right? There's just an infinite amount. It could go on forever. And you can't just say 4, because 4 is not the only answer to this. There's a bunch of answers. So the first thing we need to do is we need to have a method that lets us show what all the answers to this are without listing them, because it'd be impossible to list them all, right? You'd have decimals, fractions, 3, 4, 5, a million, right? There'd be a bunch of answers. So how we write all these answers is we use a number line. Remember, a number line is just a horizontal thing. You know, we can put, let's say you put 0 in the middle, 1, 2, 3, 4, and I'll just do a few numbers this way. And it goes on forever in both directions, right? That's a number line. So we can put the answer to this problem on a number line. Okay? And remember, a number line always gets bigger as you go towards the right, smaller as you go towards the left. So let's talk about 3 first, since 3 is the number here. Would 3 make this true if you plugged in 3 here? Would that be a true statement? No, because it'd be say 3 greater than 3. That's not a true statement, right? So I'm going to put a circle on 3, or dot on 3, and I did not fill the circle in. The reason I did not fill the circle in because 3 doesn't make this true. We'll talk about if it does make it true, what we do in just a second. And I want to put an arrow towards all the answers to this problem. So I either want to go this way or I want to go this way, towards where all the answers of this problem are. So where are all the answers for x to this problem? Are they on the left of this circle or are they on the right of this circle that make it true? I'd say the right? All those problems, 4, 5, 6, 7, a million, right? If you plug those things in for x, it makes it true. Everybody agree with that? So this is how we can write all of the answers without actually listing them all out. We put them on a number line, and then we just put an arrow to say, all the numbers from here, that way, make this true. Anything over here is false. Okay? Because technically you could put like 3.1, right? 3.1, that makes it true, but that number would be about, right here. 3.2, 3.0001 would be here. Every number from 3 that way makes it true. So this is how we can write our answers on this number line. Okay? All right, let's look at another one. If you had, say, less than or equal to 4. Okay? And I want you to put all the answers to this on a number line. Now, when you make a number line, the way I usually do it is whatever number is here, when I got the variable by itself, I just put it in the middle, and then I put a couple numbers to the right and a couple numbers to the left. You can do it whatever way you want, but that way you don't have to write out a bunch of numbers. Okay. So, first let's look at the number 4. If you plug in 4 for x, is this a true statement?
Yeah.
In this case it is, right? 4 is less than or equal to 4. So whenever that's the case, we're going to put a filled in circle. The difference between the filled in circle and the not filled in circle, we call it open and closed. That one's open, that one's closed. Is the closed one means this is part of the answer. 4 is part of the answer. The open one means 3 is not part of the answer. And then you want to draw an arrow towards all the numbers that make it true. And if you're not sure, just test a point. Let's say you tested the point 5, which is on this side of the dot. If you plug in 5 there, is it true or false? It's false, right? 5 less than or equal to 4, that's not true. If you plug in 3 there, it says 3 is less than or equal to 4, that is true. Same thing if you plugged in 2, if you plugged in 1, if you plugged in 0, if you plugged in negative 100. So that means all my answers are that way. Yes, question?
Can you just make it easier, like whatever way the greater than or less than sign is pointed?
Good question. The question was, can't I just follow, if it points that way, can I go that way? If it points that way, can I go that way? The answer is yes, some of the time. I'll show you an example where that doesn't work in just a second. I'll tell you when you can and can't do that in just a second. So the answer is yes, but not all the time. So if we just test this point 3 or 2 or 1 or negative 100, all those are answers. So this is how we write the answers, because that's way better than listing out an infinite amount of answers. We use the number line. Okay, good question. So let's look at 1 or 2 that might be like that. So I want to put the answers of these on a number line. So I'll put a number line up here. Again, you don't need to write out a bunch. I always put arrow. You need to put arrows on the end of your number line because number line's going forever, right? Numbers never stop. So let's just say I put negative 2 here, which means, again, your number lines always have to go bigger as they go towards the right and smaller as they go towards the left. So there's my number line. I just put a few points there. Now, let's start with negative 2. Is negative 2 part of the answer here? Does it make this true? If you plug in negative 2 there, negative 2 greater than negative 2? No, that's false, right? So that means we need to use an open circle. Open circle means that number is not part of the answers. Closed circle means it is part of the answer. And then I want to draw an arrow towards all the things that make it true. And you can just pick a test point. You can pick a point on this side or this side. All right. So in this one, again, we said negative 2 doesn't make this true, so we put the open circle. Okay, we put the filled in circle if that's part of the answer. And then we need to draw an arrow towards all the solutions that would make this true, either to the left of this or to the right of this. And the easy way is just pick one point and test it. If it's true, go towards that point. If it's false, go away from that point. So if you pick negative 1, 0, 1, 2, anything on this side, it would make that true, right? That's all greater than 2. So in that case, your answer should go that way. So it's still following the sign of this, the way this inequality points, right? That was the question. Does it just always follow this? Okay. So let's look at this next one. The difference is the variable's on the other side in this one, but everything else is still the same. Remember, you can read this one as 5 less than x, or if you went backwards, it would be x greater than 5, right? These two things are the same thing. Those mean the same thing. X greater than 5, 5 less than x. Okay. So if I go ahead and put my number line, I'll just, again, put 5 in the middle. I'll do a couple points to the right, a couple points to the left. In that bottom example, is that going to be an open circle or a filled-in circle on 5? It'll be an open because 5 is not part of the answer, but everything on one side or the other of that is. So I'll just test it. If I plug in 6 here, is 5, oops, let me go back. Is 5 less than 6? Yeah, that's true, right? Same with 7, 8, and so on. So that means all my solutions are that way, which is the opposite way this points. The reason is if the variable is on the left, it just so happens to follow the direction of the inequality. If the variable is on the right, it's actually the opposite way. But there's really no mathematical meaning behind that. That's just a trick to remember. What you're actually doing is you're writing down all the answers that make this true. Yes?
I thought, so is 5 a part of the thing?
So 5 would not be, because if you plug in 5 there, it would say 5 less than 5, which is false. That's why it's an open circle. If it was a or equal to, then 5 would be, and it'd be a filled-in circle. Good question. Okay. So like, whenever it's or equal to, it's going to be a filled in circle because that's part of the answer. Whenever it's just greater than or less than, it's going to be an open circle. That makes sense? All right. So now that we know how to put them on a number line, then we can solve inequalities just like we solve equalities. So if you had this, and I wanted you to solve this inequality for x, you do everything just the same as if that was an equal sign, which means you're going to do what to both sides to get x by itself? Yeah, divide by 2. You undo that multiplication by 2, so you get x is greater than or equal to 3. It's the same thing when you have an equal sign, except for one case. There's one instance that it's different. Okay. Let's again say you had this. You know, if you had this inequality, 3x plus 1 less than 13, and I said solve this inequality for x, what's the first thing you would do to both sides of the inequality? You'd subtract 1, right? Just like if that was an equal sign, you'd subtract 1 from both sides. You would get this, and then you would divide both sides by 3, and you would get this, right? It's the same thing as if there's an equal sign. Get rid of the addition or subtraction first when you can, divide by 3. And again, what we're really doing here is, if I just gave you this problem and said, give me all the things that make this true, that's pretty difficult to look at. You'd have to guess and check, and then make sure it works, and find out which way it goes. Here, I just know it's every x less than 4 makes this true. If you plug in anything less than 4 here, it's going to make this true. 3, 2, 1, 0, a half, whatever. It'll make this true. That's what we're doing when we're solving inequalities. Now, I said it's the same as an equal sign except for one case. And that case is whenever you multiply or divide both sides with a negative number. Does everybody know what happens to the inequality sign? Remember that?
Switch.
It flips. Whenever you multiply or divide by a negative number, the inequality symbol flips. Okay? Everything else is the exact same. That's just a rule we have to follow. Okay? Because if you were to plug in anything less than or equal to negative 6, like negative 10 here, that should make this true. Well, negative 30 times negative 10 is greater than or equal to 18. That's true. So anytime you multiply or divide with a negative number, you just flip the sign. That's usually the number one mistake people make when solving these. Okay, is they forget to flip it. But that's only in that case. Anytime else, it's just the same as if it was an equal sign. So, again, if you had something like this, and you had to solve this inequality for x, what would you do to both sides? We'll look at what's happening to x and undo that. Yeah, you'd multiply by negative 5. Multiply by negative 5, that cancels there. Multiply this side by negative 5, which is negative 20. And since you multiplied with a negative number, the rule is whenever you multiply or divide by a negative, the symbol flips. The inequality sign flips. So my solution, any x less than or equal to 20, or sorry, less than 20, would make this true. So that's the only rule you really need to remember there. Any questions with that? But I'm going to give you a few practice problems to work, and then we'll check our answers together here. Now on that first one, what's the first step you're going to do to start getting x by itself? Yeah, add 1, right? Add 1 on that side, add 1 on that side. 5x is left on that side. The sign stayed the same. Negative 10 on that side. Divide both sides by 5. X on that side, negative 2 on that side. Now the question on this one is, does the sign flip or not?
No.
Okay, good. And I kind of tricked you a little bit, but the answer is no, because you divided by a positive number, even though this is negative and this is negative. The rule is if you multiply or divide with a negative number. If this was a negative 5, then the sign would have flipped. It does not matter what this number is. That makes sense? Only if you multiply or divide with a negative number. I divide it with a positive number. Even though I got a negative number, this is going to be my answer. X greater than or equal to negative 2. And then if you had to put it on a number line, you could do that. In the one below, we're going to add 8 to both sides. So we have x over 3 greater than 10. Then we need to undo that division by 3. So this one's pretty straightforward. We multiply by 3, which cancels there. Multiply by 3. Does my sign flip in that case? Nope, it stays the same. X greater than 30. So any x greater than 30, if I plugged it back in here, would make that statement true. Okay. Very good. Question about those? All right, let's look at. So that top one, if you like having your variables on the left side of the inequality, you can always move them over to that side if you'd rather that. But it really doesn't matter. You can leave them on the left or leave them on the right as long as they're by themselves. So if you want to add 8x to both sides to move that over there, you can. Let's say I don't do that and I add 5 to both sides to start with. It's going to give me 64. Sign stayed the same. Negative 8x there. Divide both sides by negative 8. Now again, remember, right now my variable's on the right, so I need to leave it on the right. It's not like equal signs where you can just mix them back and forth as much as you want. You can change them, but you also have to change the sign. This is going to be a negative 8. Does my sign flip? In this case, it would. Okay? So that is a correct answer, and also if you had this is a correct answer. Those are the same thing, right? I just flipped what's on each side of the inequality, which means I also have to flip the inequality. So either negative 8 less than x or x greater than negative 8 are both correct answers, depending on if you had the variable on the left or the variable on the right. If you graph both of them on a number line, it would be the same. Okay. So both of those are correct. Either way you had it. Now, hopefully you ran into a little bit of a problem in the bottom one. I'm going to rewrite it up here. So the first thing we can do is we can go ahead and distribute that 2. You could also divide everything by 2, but we'll go ahead and just distribute. If we distribute there, the left side stayed the same. Inequality stayed the same. That becomes 6 plus 2y. No like terms that I can combine. No like terms that I can combine, so I need to start getting the variables on the same side. Since that's a positive 2y, I'll subtract it. That'll go away, which means I also subtract 2y on the other side. That leaves me with 4 on the left side, greater than 6, and then 2y minus 2y, that becomes 0, and that's all I'm left with, 4 greater than 6. The variables are gone. And I'm left with a false statement, right? 4 is not greater than 6. That's not true. Just like when we had equal signs, if the variables went away and you were left with a false statement, you remember what the solution is? Or what we say the solutions are? This is no solution, which means there is not anything that you can plug in for y in this problem that would make that true. Anything you plug in for y is not going to work. There's no solution. Because I got something that's not true at the end. Now, if I would have got 6 greater than 4, that which is a true statement, what would my answer been? What's the opposite of no solution? Infinite solutions, right? If you got something at the end that was true, there would have been infinite, which means you could plug in anything for y, and it would make it work. Okay? But in this case, there's no solution. So it is possible to get no solution and infinite solution. And obviously, we don't put that on a number line because there's nothing on a number line that works. Okay?